now for something completely different.
Hello everyone and welcome to another video on our own devices. I'm Schmid, and today we are indeed looking at something completely different. This is a Mansfield's patent water finder, patented by one Walter Mansfield around 1909 and sold by W. Mansfield and Company of Birkenhead near Liverpool, a well-boring engineering and consulting firm founded in 1900. As the name implies, this was designed to detect underground deposits of water and oil. Very cool. So, how does it work? Well, that's the thing. It doesn't. Never did, never will. And to show you what I mean, let's have a closer look at this and how it was intended to operate. So as you can see, this is a very well-constructed piece of kit. It comes in a professional-looking leather case, with the main components being made of nicely finished mahogany, brass, and glass. In addition to the case, the complete ensemble comprises the main measuring unit, a wooden base plate, 3 clip-on tripod legs, one of which is missing from this example, 2 wooden needle cases, a brass pocket compass, and a combination notebook and instruction manual. There were 4 different models of the Mansfield water detector offered, the cheapest of which could detect water down to 200 feet in depth, and the most expensive down to 3,500 feet. Now, according to the instruction manual, to use this setup, the first thing you did was drive a line of wooden stakes in the ground along a line going from northwest to southeast. You then unfold the tripod legs, attach them to the base plate, set up the assembly over the first of the stakes, and level the base plate using the included bubble level, which on this example is unfortunately cracked and mostly empty. You then align the base with magnetic north using the provided compass and this engraved white reference line. Next, you place the measuring unit on the base plate, open the door on the side of the case, and place a magnetic measuring needle on this pivot. These are protected from damage when not in use by these mahogany and brass cases. You then wait to see if the needle deflects past magnetic north, with movement past 10 degrees supposedly indicating the unambiguous presence of subterranean water or oil. According to the instructions, the best results are obtained between the hours of 8 and 12 in the morning and 2 and 5 in the afternoon and in open country on a clear, dry day. Now, according to the Mansfield Company's own literature, the principle on which the instrument works is the indicating of the presence of currents which flow between Earth and atmosphere and which, seeking the path of greatest conductivity, are always strongest in the vicinity of subterranean watercourses, the waters of which are charged with electricity to a certain degree. The spot where the greatest movement of the needle is obtained is where the boring should be made. If the needle does not move, subterranean water does not exist under the spot where the instrument is fixed. The instrument indicates watercourses flowing underground in a natural state and not water pipes or sources that have sprung up to daylight. Now, at first blush, this seems somewhat plausible. Indeed, this device is broadly similar to another instrument known as a dip needle, dip circle, or inclination compass, which measures the dip angle between the horizon and the Earth's magnetic field. The closer you get to the poles, the greater the dip angle, so with an accurate chart of magnetic variation, a dip circle can be used to accurately pinpoint your latitude. It can also be used as a crude magnetometer to locate underground deposits of magnetic ore like hematite and magnetite, which will slightly distort the Earth's magnetic field compared to its natural variation. And to learn more about magnetic variation and how to compensate for it when navigating by magnetic compass, please check out my previous video on the Polaris, course corrector, and marine computer, link in the description. Now, I said somewhat plausible because if this method of detecting water were valid, you would expect it to be still in widespread use today, only using more sensitive electronic magnetometers. But it isn't, and that's really what first set off my baloney detector. And by the way, the term baloney detector, or more specifically, baloney detection kit, comes from Carl Sagan's 1995 book, The Demon-Haunted World, which, if you haven't read, is an excellent guide to spotting pseudoscientific and other dubious claims. Now, the second thing that tipped me off that there was something fishy about this device is the sheer size and weight of the thing. The measuring needle and its protective glass case make up only a small portion of the entire instrument, the rest being taken up by this large sealed wooden compartment below. And if we flip this over, we find a paper warning sign pasted to the bottom of the case reading, "The seal of this instrument must on no account be tampered with. The instrument seldom needs repair, and such repairs can only be carried out by the manufacturers. To open the bottom compartment simply means the total destruction of the instrument. Never allow anyone to bring a magnet near the instrument or take it near electric plant." This warning is also repeated on the inside cover of the notebook/instruction manual, along with a claim that the harder the groundwater, that is, the higher the concentration of dissolved minerals like calcium and magnesium, the weaker the response of the instrument. Now, when I first examined this device, I couldn't think of any electromagnetically active component, an iron core, a copper coil, anything like that, whose performance would be affected by exposure to air or light, and this made me even more suspicious. And when I tried to open up the case to have a look inside, I found that one of the 8 screws holding the base plate in place was countersunk deeper than the others and covered over with lead or some other soft metal to prevent its removal. But after I scraped out this filler and removed the screw, I found the mysterious compartment contained this. A big cylinder made of wrapped layers of what appears to be paraffin wax impregnated paper. And it's at this point that I became completely convinced that this was an utter hoax, since this wax cylinder didn't seem to serve any sort of purpose, and this sort of breathless language about secret components in sealed containers that absolutely should not be touched by the customer is a hallmark of fraudulent product. In fact, this whole arrangement reminded me of those Beats by Dr. Dre headphones, which actually incorporate a number of steel weights which serve no practical purpose other than to make them feel heavier, since subconsciously we tend to associate heavier items with higher quality and value. However, digging a little deeper, I discovered that this design was based on an earlier patent filed by one Adolf Schmid in 1907. Indeed, Mansfield was denied a US patent because his application infringed on Schmid's. Schmid's patent states that the cylinder actually contains alternating layers of fine copper wire and tinfoil insulated from each other with wax, forming an open induction coil, which does, theoretically, make it an electromagnetically active component. However, this still doesn't explain why the compartment needs to be sealed, since theoretically exposure to air, moisture, or light shouldn't affect the operation of such a coil. And indeed, in the end, my suspicions were confirmed by this document, The Divining Rod, A History of Water Witching by Arthur J. Ellis from 1917, which reveals that the Mansfield patent water finder was just one in a long line of crackpot inventions marketed for the pseudoscientific practice of dowsing. Now, you've probably heard of this being traditionally performed using a forked twig or a pair of L-shaped metal rods held in the dowser or water diviner's hands, which supposedly dip, swing, or give some other sign as they pass over a deposit of water, oil, minerals, or whatever else is being sought. Though this practice likely dates back to antiquity, the earliest verifiable references date back only to the 16th century. Whatever the case, the practice persists to this day, even though hundreds of controlled trials conducted over the past 200 years or so have demonstrated that there is no verifiable scientific basis for the effectiveness of dowsing, with the fact that dowsers appear effective in many cases being explained by either A, aquifers being widespread in many areas, meaning you are likely to strike water wherever you dig, or B, dowsers being subconsciously attuned to subtle geographical signs indicating the presence of water. Yet, as is often the case with established pseudoscientific fields, as mainstream science and technology evolved, inventors were quick to apply these new advancements to the field of dowsing, resulting in dozens of designs for automatic water finders like this one. And indeed, by 1917, when Ellis wrote his report, there were no fewer than 24 such devices filed at the US Patent Office, with untold dozens more being sold unpatented on the open market. And apparently, these devices sold very well, at least for a few years. One report I dug up indicated that in 1913, John Scadden, Premier of Western Australia, learned about the Mansfield water finder and immediately became obsessed with it, pushing his minister to order a large number to locate suitable well sites across his arid state. And this particular unit appears to have been used for a time in the Canadian province of Saskatchewan, with the included notebook bearing several observations dated February to April 1920. However, all of these adopters ultimately realized that the instrument was, in fact, useless. See, according to Adolf Schmid's 1907 patent application, the object of my invention is an apparatus which shall indicate certain atmospheric changes, the nature and cause of which are not yet understood, but which manifest themselves in a peculiar way in the neighborhood of the source and course of subterranean waters by rapid oscillations of the pointer of my new device, the amplitude of these oscillations being as great as 50 degrees. From this, it follows that my device is particularly adapt to the detection of the source of subterranean waters and their courses. And whenever you hear an inventor use the phrase, the nature and cause of which are not yet understood, you should immediately be suspicious. And indeed, Ellis states that by 1917, extensive surveys of the Earth's magnetic field had already been conducted by organizations like the Carnegie Institution, none of which found any sign of electromagnetic disturbances associated with subterranean water or oil deposits. And this remains the case to this day, which is why, despite far more sensitive magnetometers being available, they are not used for detecting water and oil. The whole principle is just plain bunk, and sadly, despite being very well built and official looking, so is the Mansfield water detector. So that was a little bit of a different one. This is probably the first time on this channel that I've covered a device that was a complete and utter hoax, but as soon as I saw this and started digging into it, I knew I had to cover it. So I hope you enjoyed that. Thank you so much for watching, and a huge shout out to the lovely couple who allowed me to borrow this from their collection to show to you today. I'll see you next time in another video where we'll look at yet more devices, hopefully less fraudulent than this one. Until then, I'm Schmid from Our Own Devices. Have a great day.